Hello everyone, welcome to this session, and in this session let us discuss about event handling in Java program. So once you're going to have how exactly you're going to use multiple threading in Java program, so now next we'll just look into how exactly we are going to handle the events or different types of events in Java program. But before exactly we are going to understand what are events and how exactly we are going to implement, so some basics which we need to understand so before we can start implementing or actually we are going to handle a particular event. Fine, as let's get into this. Fine, so now when I'm going to talk about an event handling, so this event handling concept or the mechanism or this technique, it is the integral part of Java program or the core of Java program, which is used for creation of GUI based applications. So Java is known for that. So Java has a rich set of graphical user interface methods or classes or interfaces, and in that sense we can say, so this event handling is going to be the integral or the core part of Java program, so which is basically used for GUI based applications. And in this sense, when you're going to talk about GUI based application, applets is the first and the best example what we can look into. Hence, when we start implementing the GUI based application using Java program or as a Java program, this is what first we are going to look into, called as applets. Hence, in the coming sessions, we will see exactly how we are going to create or manage an applet. But right now, this is the best example to talk with GUI based application Java program. Hence, we are going to have applets, and when I say applet, it is going to be an event driven program. So all Java program is an event driven program itself, but it is an event driven program which is generated by the GUI, using the user interface or as a user interface. And that is what this applet will mainly use, the graphical user interface for the input, for its input. Hence GUI now is used for the input from the user, or even if I want to show or display the output, we'll be using the applets itself. Hence this is what we are going to talk about, applet as GUI based application with respect to Java. And when we are going to talk about applets, which is an event driven program, and this event can be generated through any of the input in GUI. This is the basic one. And when I say event, so event has been generated using mouse. A user will use the mouse to give the input, or a keyboard, or a button, the scroll bar, or the checkbox. So the few set of input methods what a user can use, where he can interact with the Java application, and all this will be considered as an events and individual events, and this is just at an abstract level. And as we go into the discussion and in detail, you'll see more number of different types of categorized events which will come into picture. Hence, when I'm going to say applets and events, now this applets, if I want to use in the Java program, and which is the core concept of the Java application, and this is stored in an package called as java.utility, that is short of util, and java.awt. This is going to be the window toolkit or the advanced window toolkit, and even this can be found in advanced toolkit.event. All these events will be found in this package. And if I want to make use of event handling, you need to use this packages in your program or in your application. And so now with this, when I'm going to talk about this event model, and whatever the event model right now we are going to use, the Java 1.0 version as its own event model and the way it's going to handle the events. But later on, from the 1.1 version, the 2. Java version until here, the Java is going to use a delegation model to handle the events. Hence, what is this? We call this as the modern approach for handling events. Hence, there are always two types of events models or way we are going to handle the events. The earlier one, so which was in Java 1.0, and later one, and until now whatever we are going to use the event handling, it is the delegation event model. That is what we are going to use right now, and in our discussion we will put delegation event model itself. Hence, when I say delegation event model, we are going to have something called as source, the source which will be used to give the input for the applet using GUI or anything which is going to generate an event. That is what we are going to call this as source. When an event is occurred or when an event occurs, so there should be some reason for that. There should be some cause. There should be somewhere a point where the event has started and event has occurred, and that starting point and the reason why the event has occurred, we call this as source, from where the event had generated. And when the event has generated, there should be some mechanism, some method, some logic or a piece of code which is going to help us to handle the event which has been generated by the source. The source job is just to generate or create or just pass on the event what it is going to generate. And to handle this event, what it should do, when I press a button, it's an event, it has been generated by the source, and now what do you do when the button is pressed? Should I close the application? Should I minimize the application? Should I delete some object? Should I add some object? All this thinking, the logic, the processing will happen in this listener blocks. Hence, we are going to have n number of listeners for a single source, or I can have n number of source with a single listener. In any way around it can be. Hence, we are going to have a source which generates an event. We are going to have a listener which is going to handle the event or execute the event. Hence, we are going to have this particular setup where the source will generate the events and listeners will handle the events. Hence, for this purpose, all listeners will be waiting to accept the event. It will be keep on waiting whether the keyboard is pressed or not, whether the mouse button is pressed or not, whether the user has inputted a text or not. Hence, the listener will be keep on waiting to get an event from the source. Fine. And once, as soon as the event has been received by the listener, a particular listener or any set of listeners, so that is going to process the event and it will return back the result for the source. The way it has handled, the result of event handling will be returned back to the source. And this is how we are going to work in the delegation event model. And now, why do we call this as delegation event model? This is because now when I say source, this is the actual interface what is going to be in front of the user. Hence, we call this as user interface logic. And whatever the listener have been separated from the source, we call this as the processing, where exactly the event will be processed and managed. So, which will be not in front of user or where the user cannot access this. Hence, the listeners will be behind the scene, helping out the source or working behind the scene, where it can accept the event, process it and get out the result and return back it as a output for the source. Now again, the source will be responsible to display the output for the user who has generated the event. Hence, we call this as application logic. If you just look at this, this has been clearly separated. So in the earlier version I talked about, when the event handling was there, the separation was not so clear. A source was supposed to handle every event what it gets. The source was the only responsible block which it was supposed to access and supposed to modify are supposed to handle the event and process the event. But when we brought the delegation event model, where whatever the event the source is going to get, its job is not to process now. What it does? Event has occurred, it has created the event, and the event will simply passed on to the particular listener where it can handle the event. That is what we happens in the application logic. It's clear-cut version. And now, just to put it into an technical word or technical term, the user interface logic, what I add in front of a user, application logic, what I have behind the scene for processing, and whatever the event this user interface logic will get, it will just create, generate, and pass on to the application logic. It does nothing with the processing. Hence, we call this as delegates. The pass on, we are putting technically it as delegates. The user interface logic will simply delegate whatever the event it gets to the application logic. And this is what we call this as delegation event model. Hence, when we are going to have this delegation event model, I can have n number of sources, as I told you, and whenever a listener should be capable of receiving an event from a source, it should register itself. First job is the source 1 should have at least one listener which has been registered with this. It should be at least one. It can be more one, but it should be at least one. And a single source can have mapped or registered with n number of listeners. Fine. Hence, when this source is going to generate an event, this event will be passed on to all the listeners which has been registered. Depending upon type of the event, that particular event will be passed on to the listeners what it should handle. Hence, a single source can have a single listener or it can have multiple listener. But whereas this two listener has been not registered with the source 1, hence this will not receive any event. Whereas this is registered with the source 1, hence whatever the event the source 1 is going to generate will be received by this listener and will be able to process. Whereas this 3 listeners are registered with the source 2, hence whatever the event the source 2 is going to generate will be accepted and processed by this listeners, all these 3 listeners. And whereas when I going to talk about source 1, if it generates, it will be handled only by this listener. And just observe, this listener is registered with both the sources. Hence, a single listener can be registered but multiple sources, and a single source can have multiple registered listeners. This is how the delegation event model is going to work. Until unless a listener is not registered with the source, it cannot receive an event. Hence, it's of waste if you're going to have such listener in your application or system. This is what we call this as a delegation event model. Now with this, I was just saying I'm going to have a source which is going to generate an event. Now what is an event then? So event is an object in your Java program. Event is an object which is going to describe a state change in a source. A source is waiting, it's a state. When a user presses a button, the source is going to change its state. From waiting, it is going to receive. From receive, it's going to create an object or an event as an object, and it's be passed on to the listener. And this is what change in state is going to be. And whenever there is going to be change in the state in a source, that is where the event has been generated. And so from where the events can be generated, from where the change in the source can appear, in this following cases. Whenever there's an interaction from the user, something like this. When he's going to type a string and presses OK. So typing the string is also an event. Pressing OK is also an event, or pressing cancel is also an event. Clicking on this close window is also an event. Similarly, even with this, and that is where the interaction of by the user will generate set of events, or when the timer is going to expire. That is, now if I am going to have such a dialog box, and if I am going to put a timer over here, and in that time if you don't choose or don't click any of this button, automatically the window should close. That is what we are going to say timer expires. Once the time is going to expire, I am going to close the window, or itself is going to close the window, and when there is a change in the state, hence the event will appear. And when the counter exits, I am just going to put a counter here. Instead of having a timer, I am going to put a counter, so which is going to be similar to time expires but in the reverse way. And when certain operation is completed, so now the window should wait for certain amount of time, and once this is done, or when I'm going to perform some copy operation, moving a file from one folder to other folder, it's an operation, and once the operation is completed, the window will automatically get closed and there's an event. Or whenever there's going to be software or hardware error which can occur when the application is running. And these are the few cases where the events can be generated and which should be handled in your program. And with this events, now when you talk about the event source, I don't know what type of event or where the event is going to be, but now just talking about the event source again, it is the object that generates an event. So this is an object, or it's a class which is going to create or generates an event. So occurs when internal state of object changes, as I just explained. And sources may generate more than one type of event. So pressing the mouse button can activate a text field. So pressing a mouse button can activate a button or click the button, or pressing a mouse event, I can close a window. Hence, a single source may generate more than one type of event, and all this source must be registered with the listener. Any source you talk about, and if you think there should be a source, keep in mind it should have its own registered listeners. If there is no registered listeners, then the event is generated will never be handled and it's of no use. And the registered listener will receive notifications of the event of specific type of event, whatever it's going to generate. And each type of event has its own registration method. When whatever the event I'm going to take will be having its own registration method. There is one single registered method will not handle every event of the source. From a source for a specific event type, there is going to be a method, and that method should be registered, and registered method will receive the notification whatever that particular source is going to generate. So this is how the event source is going to work with. And whenever I want to register an listener to the event source object, this is the function which we are going to use. It's a public, returns nothing. So add, that is, I'm going to add a new listener now. Type listener, and now this type is going to be the type of the event what I want to add. And the type listener EL, and this EL is going to stand for event listener. I'm going to have an event listener. So reference, so which is going to tell me which event listener should be called. Hence the name of the event is the type, and the event listener actually which I need to call when this type of event occurs. So this event listener will be called to perform or to process. Hence, just for an example, just look at this. If I want to add a keyboard event or the keyboard as a source, now I am going to add this listener. Add key is the type of the event, the keyboard, and listener. And add, so mouse motion is the type of the event which I am looking into right now. So right now, do not bother about this particular parameter. We will see it later how exactly we are going to create an event listener or how we are going to exactly use the existing listener. But right now, don't worry about this parameter. Just think what type of listeners I can register with a specific source. And now whatever the events type have been registered, so now all these event types, we call this as multicast. That is, if I am going to add these two listeners or these two events for a single source, in case if I am adding the same two listeners for the same event source, then when the event is going to created or when the event is generated, so these events are passed for both these methods. Hence we call the events are multicast. For all the listeners, whichever has been registered, for all those listeners, the event will be passed. And so now, when I say a source can have a single listener or source can have multiple listener. By default, if I am using this function is going to make sure you are going to add any number of listener for a single event source. But there is a certain situation where you don't want multicast to happen. You want one source to have with only one listener. That is what you want, a unicast, not multicast. If that's the case, the same function I'll be using, but I need to add on the exception handler. So where we are going to say this method will be throwing Java utility dot too many listeners exception. And so now you can attach or you can register only one listener for the specific object now. If you're trying to add the second listener, you're going to end with the exception called as too many listeners exception. If I'm using the same method with this particular exception, we are going to have an object or an event which will be only one listener. Hence the event is now an unicast. So right now we are going to have an event. The event has been registered. So right now, what if I don't want this listener to be handle my event? I want another listener which will be capable of handling the same event. In that case, you can remove or you can unregister. You can unregister a listener from an object source. If you want to unregister, we are going to use the function remove type listener. So this is going to remove or this is going to unregister any type of event from listener from an object. So three functions which you can make use of, either to register or to unregister. And this is just an add-on how exactly you can make any object to be unicast. And with this, when I say an event listener, a listener is an object that is notified when an event is going to occur. Hence, whenever we are going to have a listener which is also an object. So you know what is event source now. When I talk about the event listener, again which is an object, and so this listener should work in two parts. You should always have these two parts. The first part is, as I told you, the listener should be always registered either with one source or more than one source, but listener should be registered at least with one source, and this listener should be implemented. It should be implemented so that it can receive and process any event notification from the source. Hence it should be registered, the step 1, the step 2, the method or the process logic should be implemented so that it can handle the event which it has been registered by itself. Hence when I talk about event listener, just think about these two parts. Register and make sure you have a method implemented to handle that particular event which will occur from the source. And so now with this, when I say method that receives some process events are defined in set of interfaces. Now whatever the methods which is going to receive and process the events or defined in set of interfaces. Now your job is look at the interface, look at the method available in the interface and implement the appropriate method from the interface. And this interface is going to be stored in java.awt.event. If you include this package, you will be having set of interfaces where each interface is going to contain set of methods which should be implemented to handle the registered type of event. And this is how we are going to talk about the event listener. Hence we are going to have an event source. You know about this at this point. You're going to have an event listener, and now you know what is the event listener. And now to have all these things, fine, to create an object, to create an event object or to create listener object, what do I need? I do need a class. So through that class itself, I can create or I can manage any object. And that is where we are going to talk about an event object. We are going to have a class called as event object, and this event object class is the topmost class in the class hierarchy when you talk about event handling. So remember this, the event object is the topmost class in the class hierarchy whenever we are going to handle an event. Hence we call this as root of Java event class hierarchy. And this is available, all the classes which I do need to handle an event is available in java.util. Fine. And so now if I talk about this event object, this is going to have a constructor, so which is going to accept an object source, and this is the source which is going to generate the event. And when this source is going to generate an event, we are going to generate an event object, and this class will accept the source reference, and from that source reference it is going to create an event object. And it is going to have two more methods other than this constructor. It is going to have two more methods. This method is going to say get source to know what type of source currently the event object is going to handle. If I want to know what type of source, I am going to use the method get source. And so this event, if I want in the form of string, the form of name, I am going to use the toString method. Hence I am going to have event object class, which is the topmost class of any event class what we are going to talk about. And we are going to have this following constructor and the two methods. And now I am going to have one more class called as AWT event, Advanced Window Toolkit event class. This is a class so which has been inherited by the event object class. As event object is a super class and AWT event is a subclass. Hence, and this class is available in the package java.util, and this class is available in the package java.awt. Now this is the main class what we are going to use whenever we are going to talk about graphical user interface. AWT application is what I require, and to generate a AWT application or a GUI application, this class is the important class. And for this case we are going to have this as a subclass, and I'm going to have superclass. Hence right now the event object is at the top of the event class hierarchy, and it has got one method other than this methods. It has got one method now which will be used to know what is the type of the event. So this is going to give me the type of the source or the source name. This is going to give me what type of the event I am going to have. And further now whatever the subclass I am going to have in the AWT based events or GUI based Java application, and which is used by the delegation event model, all these subclasses, just observe here why I am saying that subclasses, because these classes are inherited. All these classes are inherited by the AWT event class. Hence, the AWT event class will be a super class for all the class which is going to belong or which is going to handle an event being in AWT environment or the graphical user interface environment. And this is where it is going to be the subclass. Fine. And so if you just look at the hierarchy, this is the topmost class, event object, and this is the subclass of event object, and all these classes what I discuss will be under the AWT event class itself. And if you just look at the few classes, so there are a lot of classes, many classes which we can list out, but right now I am restricting myself to few classes which will be the important classes, so which we can make use to develop and manage an applet. Hence, I have just put few classes, few list of classes over here. So the action event, which is a subclass of AWT event, adjustment event, component event, so on. I am just going to have this set of classes which is inherited by AWT event. Further, again this inherited by event object, and this classes is available in the package java.awt.event. Hence, these are the few classes which we need to bring in for discussion. So in the next session, individually we will see what is the purpose of these classes and how exactly we need to use these classes when it comes to the implementation part. Hence, so this is all for this session. Thank you.